All right, CPM Math 3, problem 1-19. We're solving quadratic equations. This was a huge piece of Math 2, and it is assumed that you are pretty much experts at being able to solve quadratic equations. So if you do struggle with this, you need to get into tutoring or get some kind of assistance. So the three major ways that we solve quadratic equations are using the zero product property, or by completing the square, or by using the quadratic formula. Students usually have favorites, but a lot of times the favorite isn't always the fastest. So for part A, is this little guy factorable, x squared minus 8x plus 15? That makes me wonder if there are any two numbers that multiply together to be positive 15 but add together to be negative 8. And right off the bat, if you want to use a diamond problem, you could put the 15 up here and the negative 8 here, and we realize then that negative 3 and negative 5 multiply together to make positive 15, but add together to be negative 8. So you can factor this little guy. He becomes x minus 5 and x minus 3 equals 0. And the zero product property then states that we would take each of these expressions, set them equal to 0, and we would know the value of x. That would force a 0 answer. Okay, so x minus 5 equals 0, so x would have to be 5. X minus 3 is 0, so x would have to be 3. All right, look at how fast that was. Seriously, come on, folks. You can do this. You can factor. And for part B, to be honest, am not sure if it's factorable or not, but I'm going to test it using our strategy, using the area model and diamond problem. Let's see if it works. If it doesn't, it doesn't, and that's okay. We're going to put the a value, a term, 2x squared in the bottom left, negative 6 c term in the top right, and we multiply diagonally to get negative 12x squared. And that negative 12x squared goes up top in the diamond problem, and then the b value, goes in the bottom, negative 5x. And what we want is we want two numbers that multiply together to give us negative 12x squared, but add together to give us negative 5x. And let's do just a little bit of mental math in order to figure that out. All right, so the factors of 12 are 12 times 1, or 2 times 6, or 3 times 4. And there is no way to take 12 and 1 and add it together or subtract it in order to get negative 5. 2 and 6, same thing. There's no way to get negative 5. 3 and 4, there's no way to get negative 5 out of there. So what that means is that this expression is not factorable. So we are going to have to find an alternate method. All right, factoring won't work. All right, now, could we complete the square? Questions to ask. Is B even? Oh my goodness, nope, B is not even. Is A 1? You can do it when A is not 1 with this 2 here, but it does get complicated. And a lot of little arithmetic mistakes happen. So what does that mean? That we have to use the quadratic formula. All right, so let's start plugging stuff in. All right, so the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, and all we have to do is simplify that, and I'm going to do that fairly quickly here in order to not take up too much time in the video. And so when we plug everything in, or excuse me, I should use the word substitute, we end up with x equals 5 plus or minus the square root of 73 over 4. This is considered the exact form. If you wanted to take the square root of 73, you could get the approximate form, which either one in my book is acceptable. You can leave it like this and get full credit, or you can actually do all that detailed math. Let's do that as well. All right, so when you break this down, the square root of 73 is approximately positive 8.54 or negative 8.54. And we like to break it out into two, because it is two separate answers. So what you're seeing here is it being broken out 5 plus 8.54 over 4, which is approximately 3.39. Notice it is an approximate value, and x equals negative 0.89. These are approximate. These are considered we have two irrational solutions because you cannot fully grasp the entire solution.